Okay, so in the vast majority of algebra at junior cert and in the last two videos we've explored quadratic equations and quadratic curves. At leaving cert though, we need to be confident talking about cubic equations or cubic curves, and then x to the power 4s and x to the power 5s and x to the power 6s, which the umbrella term for curves, or x to the higher up I go, the umbrella term for them is just polynomials. Polynomials in general are just curves with any amount of turning points. The ones that come up very, very often at leaving cert level are cubics. A quadratic or a plus x squared, is a U shape, and it has one turning point and it has two roots. You also know from junior cert that a minus x squared has one turning point and it has two roots. In other words, they tend to cross the x-axis twice. However, we also need to be confident with what a plus x cubed looks like and what a minus x cubed looks like. If it's an x to the power 2, it's going to have one turning point. If it's an x to the power 3, it's going to have two turning points. If it's an x to the power 4, it's going to have three turning points. An x to the power 10 is going to have 9 turning points. So basically just subtract 1 and that's the number of turning points. The plus x cubed, the shape of a plus x cubed, it starts the same way as a minus x squared. That's the way that I always remember it. A minus x squared is an N shape, and a plus x cubed starts as an N shape and then is a U shape like this. There's two turning points, so that's the shape of a plus x cubed. A plus x squared starts as a U shape, and as does a minus x cubed. It starts as a U shape and then forms an N shape. That is all of the shapes that you need to know for polynomials, because all of the even powers start off the same way as the x squareds. All of the odd powers start off the same way as the x cubeds. So for example, let's take a complicated one, like imagine a plus x to the power 6. If I had a plus x to the power 6, 6 is an even number, so it follows the same rules as the x to the power 2 because it's also an even number. So if it's x to the power 6, it has 5 turning points, and I know that it will start off the same way as a plus x squared. So it'll be a U shape, and it's going to have 1, 2, 3, 4, 5 turning points. So it's going to look like that. An x to the power 6, it starts off the same way as an x to the power 2. I here have 1, 2, 3, 4, 5 turning points. To be honest, we rarely come across anything bigger than an x to the power 3, although we do need to talk about it in this video. The vast majority of polynomials that we deal with are x cubed or just x squareds. Okay, the questions on this material are incredibly straightforward. Let's have a look at example 1 here. In the first example here, we're told that a cubic curve has roots x equals 2, x equals minus 1, and x equals minus 3. That, in other words, it cuts the x-axis in 3 different places. I know that if it has 3 different roots, it must be an x to the power of 3, or in other words, it's a cubic curve, and it has 2 turning points. Now, the first part of the question says, if the curve cuts the y-axis at 0 minus 6, write the curve in the form ax cubed plus bx squared plus cx plus d equals 0. For the moment, don't worry about the 0 minus 6. We'll talk about that when we get to our answer. But let's just focus. We have our 3 roots and we've been asked to write the curve in the form of a cubic, as an x cubed, an x squared, an x, and then a number. It's relatively straightforward to do this, and we're going to follow the same logic as we followed when dealing with quadratics. If I know the roots, I want to turn each root into a factor, and if I multiply all the factors by each other, I'll get the cubic, or I'll get the polynomial. Once we've done that, we're then going to sketch the curve. If we're asked to sketch the curve, it's relatively straightforward. It just means you need to get the shape right, and it needs to cross the x-axis at the right point. So let's first of all have a look here. If we were to start this one off, if we just look at part 1, we're asked to write the curve in the form ax cubed plus bx squared plus cx plus d. In order to do that, I need to turn my roots into factors. If x equals 2 is a root, I subtract 2 from both sides and I get x minus 2 is one of the factors. If x equals minus 1 is a root, I add 1 to both sides and I get x plus 1 is the second factor. And if x equals minus 3 is the third root, I add 3 to both sides, and I get x plus 3 is the third factor. So now I have my three separate factors. And if I multiply these by each other, I'll get ax cubed plus bx squared plus cx plus d. This is basic enough algebra, so I've skipped a few lines here. What I would suggest you do first is multiply just two of the brackets. Multiply x minus 2 by x plus 1. In order to do that, it's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. And if you multiply x minus 2 by x plus 1, you'll get x squared minus 1x minus 2. Then we have to multiply that quadratic by the third factor, which is x plus 3. Probably the easiest way to do that is to take this x, multiply it by the quadratic, and then plus 3 and multiply it by the quadratic. And if you multiply that out, you should get x cubed plus 2x squared minus 5x minus 6 equals 0. So that tells me that if these are the three roots, then these are the three factors. When I multiply the factors by each other, I get this cubic. This is a cubic because it's an x to the power of 3. It's in the form ax cubed plus bx squared plus cx plus d. And this is an example of a cubic that has these three roots. However, the problem is there are an infinite number of cubics that I could draw that have these three roots. There's millions, there's an infinite number of them that would have these three roots. This is simply one example of a cubic that crosses the x-axis at 2, minus 1 and minus 3. When we sketch the curve in a moment, we're going to explore all the different ways, all the different curves that could cross the x-axis in these three places. But the question has told me the curve, the y-intercept is 0, minus 6. It crosses the y-axis at 0, minus 6. Remember from your quadratics that the constant at the end indicates the y-intercept in a quadratic. That applies to any polynomial, any cubic or an x to the power 4, or x to the power 5, or x to the power 50, it doesn't matter. If there's a constant at the end, that indicates where it crosses the y-axis. This one has a minus 6 at the end. That tells me it crosses the y-axis at the point 0, minus 6. So I know, so first of all, this is just an example of one cubic that has these three roots, But if it goes through the point 0, minus 6, then I know that this is the one I'm actually looking for. So my final answer to part 1 is this one. Now, if you're not 100% on that, give it a moment, we'll look at the graph and it'll make a lot more sense. So once we've drawn our cubic, we're now being asked to hence sketch the curve. So let me just wipe out what I had at the start. Okay, so I'm going to wipe out this and we're going to sketch ourselves a curve. We want to keep the different roots. So I'm going to just mark up here that the roots, the points where it crosses the x-axis are x equals 2, x equals minus 1, and x equals minus 3. I want to keep those because it's going to help me to identify where it crosses the x-axis. And I want to keep what I got in part 1 because it's going to help me to identify the shape of the graph. This is a plus x cubed. As we've explored previously, a plus x cubed needs to be this shape. It starts off the same as a minus x squared and it has two turning points. Again, sketch, it literally is what it says on the tin. Sketch, you just need to, it doesn't have to be to scale, it doesn't have to be accurate, you just need to mark in the right points. I need to draw this shape and I need it to cross the x-axis at minus 3, the x-axis at minus 1 and the x-axis at 2. And the y-axis at the point 0, minus 6. The constant at the end indicates that it crosses the y-axis at 0, minus 6. So I need to, now at this point, you make sure you get your shape right. A lot of students often get their shapes wrong. We're not drawing a shape like this. That is a cubic, but that's a minus x cubed. We're drawing a shape like this. It's a cubic, but it's a plus x cubed. So I could just sketch myself a graph. I know that there's a maximum point somewhere up here, and then I go down. I know it crosses at minus 6, and then there's a minimum point, and it intersects at 2. So this would get me full marks for part 2. It asks me to hence sketch the curve that crosses the x-axis at minus 3, minus 1, 2, and is a plus x cubed. So that's the final answer for example 1. However, let's now explore different cubics that have the same roots. Imagine if in part 1, like in part 1 I could have told you that it crosses the y-axis at the point 0, 6 rather than 0, minus 6. If I had told you that it crosses the y-axis at the point 0, 6, when you would have done the exact same maths, you would have turned your roots into factors, multiply the factors by each other, and you would have gotten a cubic. But when you got to your cubic, you would have had to realise that this is not correct, because the constant at the end here is a minus 6. I don't want a minus 6 at the end, I want a plus 6 at the end. So at that point, you just have to ask yourself, right, well, what do I need to do to this constant? What do I need to multiply it by in order to turn it into a plus 6? Clearly, in order to turn a minus 6 into a plus 6, I need to multiply it by minus 1. So that would indicate that you need to multiply everything by minus 1. If you were told that you had a cubic that has these three roots and it crosses the y-axis at 0, 6, you would have done all the same maths, but at this stage you would have multiplied by minus 1 so that the constant at the end corresponds to this y value. If I multiply everything by minus 1, I get minus x cubed minus 2x squared plus 5x plus 6 equals 0. And that would have been your answer to part 1 if this had been the y-intercept. And the sketch would have been slightly different as well. I want you to realise that this is a minus x cubed. A minus x cubed is this shape rather than this shape. But I'm dealing with the same roots. It still crosses at minus 3, minus 1 and 2. The difference is it crosses the y-axis up here at 6. So in this case, if I was trying to sketch my curve, I would try and sketch this shape. It would cross at minus 3, it would cross at minus 1, it would cross the y-axis at 6, and then the x-axis again at 2. Again, I know my sketch is probably not great, but if it's a sketch, once you've indicated all the right intercepts, then you'll get the marks. So I just want you to be aware of that. If this comes up in the leave insert, I imagine that's the kind of complication you'll get. You take your roots and you turn them into factors. You multiply your factors by each other to give you the polynomial, and then you look at the constant at the end and you investigate if it corresponds to the y-intercept. Like, for example, I could have said 0, 12. If I had said the y-intercept was 0, 12 rather than 0, 6, that means you would have wanted to turn the minus 6 into a plus 12. In order to turn minus 6 into plus 12, you would have multiplied by minus 2. And in that case, the curve would be twice as steep as this one, but it would still cross the x-axis in all the different places. I want you to realise there's an infinite number of cubics that I could draw. I could draw twice as steep, 3 times as steep, 4 times as steep. So there's an infinite amount of possible cubics that have these three roots. So the types of questions that we're actually going to look at in this video are questions like this, where you're given a polynomial graph and you're asked to write the following polynomial in the form ax cubed plus bx squared plus cx plus d. The key here is that you can identify what the roots are, and you can identify where it crosses the y-axis. So by identifying the roots, I can convert the roots into factors and multiply them by each other, and then I'll be able to write my cubic in the form ax cubed plus bx squared plus cx plus d. First of all, it's obviously a cubic equation because there's two turning points. If there's two turning points, it must be an x to the power of 3. Also, it has exactly 3 roots, so it must be an x to the power of 3. From this diagram, I can identify the roots. The first point where it crosses the x-axis has been marked as minus 7. So one of the roots is x equals minus 7. The second point where it crosses the x-axis is 2. So I know that x equals 2 is also a root. The third point where it crosses the x-axis is at 3, so I know that x equals 3 is a root. What I can do now is just move those numbers to the left-hand side and I'll have 3 factors. If I multiply the 3 factors by each other, I'll be able to get the cubic in the form ax cubed plus bx squared plus cx plus d. So the maths here is quite straightforward, you just need to be meticulous about it. The roots are clearly x equals minus 7, x equals 2 and x equals 3. X equals minus 7, I add 7 to both sides and the corresponding factor is x plus 7. If x equals 2 is a root, the corresponding factor is x minus 2. And if x equals 3 is a root, the corresponding factor is x minus 3. If I then multiply the 3 factors by each other, I'll be able to generate the cubic. So what I've done here is I first decided to multiply x plus 7 by x minus 2. So it's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. When I multiplied it out, I simplified it down to x squared plus 5x minus 14. What I then decided to do was to take the first thing in the second bracket and multiply it by this, second thing in the second bracket and multiply it by this. X times the quadratic minus 3 times the quadratic. I multiplied it out and grouped all my like terms and got x cubed plus 2x squared minus 29x plus 42 equals 0. But now I need to look at this cubic and I need to compare it to the graph and see, does it match up? Because the cubic I've come up with definitely has roots x equals minus 7, x equals 2 and x equals 3, but there's other things that I need to look out for from this example. Remember that there are an infinite amount of cubics that have the roots minus 7, 2 and 3. And the one that we've generated is not the one we want. When we turned our roots into factors and multiplied them by each other, we got x cubed plus 2x squared minus 29x plus 42. There's a couple of things I can tell about this graph. It's a plus x cubed. I know a plus x cubed starts as an N shape and then turns into a U shape. It starts off the same way as a minus x squared. Clearly the graph that I originally had is not that shape. So it's definitely not a plus x cubed, it must be a minus x cubed. I can also tell that this graph would cross the y-axis at plus 42, which is somewhere up here. Clearly my graph is crossing at minus 42. So something doesn't add up here. I need to figure out, what do I need to do to this cubic so that it satisfies the conditions in this graph? Obviously I need to change its shape. It needs to be a minus x cubed. So in order to change its shape, I need to multiply it by minus 1. And if I multiply it by minus 1, this will become a minus x cubed, so that a minus x cubed I know starts as a U shape and then an N shape. And I notice that if I multiply 42 by minus 1, I'll get minus 42, and that adds up because clearly this graph crosses the y-axis at minus 42. So these questions are quite straightforward, and the vast majority of students get to the point where they've turned their roots into factors and they've managed to come up with a cubic, but not necessarily the correct cubic. It's the last line or two that's really, really important. The one that we've come up with in the previous slide, it doesn't satisfy the conditions of this graph. It only satisfies the conditions of the roots. What I need to do is multiply everything by minus 1. And the cubic that I've actually been given in this graph is minus x cubed minus 2x squared plus 29x minus 42 equals 0. So minus x cubed, which is a U shape and then an N shape, and it crosses the y-axis at minus 42. So this is my final answer to the question. So I think we'll do one more example and then I'm going to give you a few questions to try yourself. Okay, the final example I'm going to do in this video is this one. You could be asked to write the following polynomial in the form ax to the power of 4, then an x cubed, an x squared, an x, and a number. Notice that this time, this is a polynomial that has 3 turning points. It's x to the power of 4. And x to the power of 4 has 4 roots. What I can clearly see here is that it turns on the x-axis at minus 3 and it turns on the x-axis at 2. And its y-intercept is 72, which might come into play later in the question. If I can identify the roots of a polynomial, I can write it in this generic form. Remember that if there's a turning point on the x-axis, that means that there's 2 roots at this point. So 2 of the roots for this polynomial are x equals minus 3. It also turns at x equals 2. So I know there are 2 roots at that point as well. It turns at x equals 2 and x equals 2. Now this makes sense. So you should always just double check that it adds up. If it's an x to the power of 4, there should be 4 roots. And if there's 4 roots, there should be 3 turning points, which there clearly is in this case. So what I want to do now is convert each of these roots into factors, multiply all of the factors by each other, and write my polynomial in this form. So again, the maths here is quite straightforward, but you do need to pay attention to detail. My roots are x equals minus 3, 2, and then 2. I can convert each of those into factors and then multiply the factors by each other. So what I decided to do was first of all multiply x plus 3 by x plus 3, and then multiply x minus 2 by x minus 2. When I multiply x plus 3 by x plus 3, I ended up with x squared plus 6x plus 9. And when I multiplied x minus 2 by x minus 2, I got x squared minus 4x plus 4. I then took the first thing in the first bracket, multiplied it by the second bracket, second thing in the first bracket by the second bracket, third thing in the first bracket by the second bracket. and I ended up with 9 separate terms here. What I then did was I grouped my like terms, and I ended up deducing that a polynomial that has these 4 roots can be written in the form x to the power of 4 plus 2x cubed minus 11x squared minus 12x plus 36 equals 0. That doesn't necessarily mean that this polynomial matches the graph I've been given. So now I need to go back to my graph and look at the shape of the graph and look at the y-intercept of the graph and see does it match up with what I've worked out. However, the problem lies in the fact that the number at the end of this polynomial is at 36. That implies that this polynomial intercepts the y-axis at 36. From my diagram, it is clear to see that our polynomial intersects at 72. So I need to figure out what do I do to plus 36 in order to turn it into a plus 72. Obviously 36 is just half of 72, so what I need to do is I need to multiply everything by 2. If I multiply everything by 2, I get 2x to the power of 4 plus 4x to the power of 3 minus 22x squared minus 24x plus 72 equals 0. This is an example of a polynomial that has 2 roots at x equals minus 3, 2 roots at x equals 2, and intercepts the y-axis at 72. So my final answer to example 3 is actually this. Okay, so the first question that I want you to try is this one. In this case, you're asked to write the following polynomial in the form ax cubed plus bx squared plus cx plus d equals 0. You have a polynomial that has 2 turning points, crosses the x-axis at minus 3, 3 and 5, and clearly intercepts the y-axis at 0, 45. So I want you to pause the video now, and I want you to come up with a cubic. I want you to write it in this form, and it needs to match the curve that's been given. Okay, so to start this one off, I need to identify the roots. The first point where the curve crosses the x-axis is at minus 3. So I'll write that root as x equals minus 3. The second one is x is equal to plus 3, and the third one is x is equal to 5. I'm going to take each of these roots and convert them into factors and multiply them by each other so that I can write my cubic or my curve in this form. Once I've identified the roots, I simply convert them into factors and multiply them by each other. So I need to multiply x plus 3 by x minus 3 by x minus 5. I started off here by multiplying the first 2 brackets by each other. When I multiplied x plus 3 by x minus 3, I ended up with x squared minus 9. Then I need to multiply x squared minus 9 by the third bracket that I've thus far ignored, it's x minus 5. It's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. When I multiplied it out, I got x cubed minus 5x squared minus 9x plus 45 equals 0. So now I need to go back to the graph that I've been given and see, does this match up with the graph? Is it the right shape? Does it have the correct y-intercept? So I need to figure out if the cubic that I've come up with matches this curve. This one is a plus. There's a plus in front of the x cubed. And I know that a plus x cubed, it starts off the same way as a minus x squared. In other words, it starts off as an n and then turns into a u. So the shape is okay. The other thing you need to look out for is the constant at the end, does it correspond with the y-intercept? The plus 45 here indicates that what this cubic should intercept the y-axis at 0, 45. So clearly this one is right. That's my final answer. I don't need to manipulate it at all. It's the right shape and it crosses the y-axis at the right point, crosses the x-axis at minus 3, 3 and 5. So this is my final answer for question 1. Okay, the second question now is similar again. You need to write the following curve in the form ax cubed plus bx squared plus cx plus d. Once again, there's 2 turning points and 3 roots. This time it crosses the x-axis at minus 8, minus 1, 6, and it crosses the y-axis up here at 0, 96. So once again, the first thing you need to do is you need to write out your roots. And when you've written out your roots, you need to convert them into factors, multiply them by each other, and then make sure that the resulting equation matches your curve. So I want you to pause your video now, and I want you to attempt it yourself and then compare it to my solution. So in this case, the first root I have is x equals minus 8. The second root we have is x equals minus 1, and the third root we have is x equals 6. I'm now going to convert these into factors and multiply them by each other to generate a cubic. So once we have our 3 roots, we simply convert them into factors and multiply them by each other. So what I've done here is I've multiplied my three factors by each other, and I ended up with x cubed plus 3x squared minus 46x minus 48 equals 0. I know that a polynomial that has these three roots can be written in this form, but that's not necessarily the one that I've been given in my diagram. So all I know now is that a cubic or a polynomial that has roots minus 8, minus 1 and 6, it could be written like this, but that's not necessarily the curve that we're dealing with. There are two issues with this that don't match up to my curve. First of all, this is a plus x cubed. And I know that a plus x cubed begins the same way as a minus x squared. I know that it begins as an N shape and then a U shape. Clearly not what we're dealing with here. So there must be, in this curve, it must be a minus in front of the x cubed. The second problem is the y-intercept. The one that I've come up with has a y-intercept of minus 48. Well, clearly the one I've been given has a y-intercept of plus 96. So I need to think, what should I multiply this variable or constant at the end by so that it becomes a plus 96? What you need to do is multiply minus 48 by minus 2. If I multiply minus 48 by minus 2, I'll get plus 96. That tells me that what I need to do to the cubic I've come up with is just multiply everything by minus 2. That will solve the problem of the sign in front of the x cubed and also the y-intercept. So if I simply multiply everything by minus 2 now, I'm going to get minus 2x cubed minus 6x squared plus 92x plus 96 equals 0. And that's my final answer. This cubic describes what we see in our curve here. So that's all I want to talk to you about in this video. The maths is relatively straightforward. The one thing you just always need to look out for if you're given a graph, come up with your cubic or your polynomial and then just double check it matches the shape and double check it matches the y-intercept.